Properties of rhombuses. So once again, a rhombus will have all the properties of a parallelogram, but then in addition to those properties, it's going to have some special ones all to itself. Okay, and these deal with the diagonals. So for a rhombus, the diagonals are perpendicular, so they come together at a 90-degree angle. They also bisect the opposite angles. And so when you think about the diagonals for a rhombus, that means it has another property too. The diagonals also bisect each other. Because it's still a parallelogram, it still has those properties as well, okay? But in addition to those, they're also going to be perpendicular and they're going to bisect the opposite angles. For example, when I look at these guys, it says find the angles in each rhombus. So I'm telling you the directions are saying that this is a rhombus. And so if this is a rhombus, that means the diagonals are perpendicular, which means when these two diagonals cross, they'll cross at a 90-degree angle. And so when you look at something like angle 1, well, angle 1 is where these two cross. So that has to be a 90-degree angle. So now I automatically know the measure of angle 1. Looking at the rest of these, let's see, the measure of angle 2. I'm just going to write them all down here. As I kind of work my way through these, notice right here I have this guy at 52 degrees. Well, because the diagonals bisect the opposite angles, that's one of the special characteristics of a rhombus. It means that this guy right here next to it also has to be 52 degrees. That's what happens in the diagonals of a rhombus. And then because of the fact that this whole thing is also a parallelogram, remember a rhombus is a parallelogram, it means that the opposite angles are congruent. So this set of angles is the same as this set of angles. So right away, angles 2 and 3 have to be the same as the angles on the opposite side. So each of those has to be 52 degrees as well. Okay? And then from here, there's a couple ways we can look at this. If I were to kind of jump back up here to this guy, the one where the angle started, well, right away, if that's 52 degrees and then I have a 90-degree, this is a triangle that's being created in here. If I look at this triangle, well, the three angles inside a triangle have to add up to 180 degrees. And so if those add up to 180 degrees, I already have a total of 142 degrees when I look at these two angles. So I do a little bit of subtracting. That gives me a 38 degrees. Well, that's this angle right here is 38 degrees. And so when I apply that now to the fact that this is a rhombus, well, that angle is being bisected. So if this one is 38 degrees, well, at angle 4 also has to be 38 degrees. Okay? This is some of the special properties involved with a rhombus. Okay? If I look at the next one, same kind of thing. Notice I only have one of the diagonals drawn. Okay? But the diagonals bisect the opposite angles, which means all four of the angles that I see here, this angle and this angle have to be the same. This angle and this angle have to be the same. And because they're across from each other in a parallelogram, well, the angles over here have to be the same as the angles over here. So really, all four of these angles are the same. And it once again comes down to the fact that when I draw these diagonals, I'm now creating a triangle. And so when you look at this, these three angles inside this triangle, right here, when I look at this obtuse triangle over here, those three angles have to add up to 180 degrees. Right now I have 102 degrees, so if I do a little subtracting, that leaves me with 78 degrees. But that's split between two angles. But see, the fact that this is a rhombus tells me those two angles are the same. Well, that means that they have to be divided evenly among those two angles. So I'm going to divide by 2, and that's going to give me a 39 degrees for each of them. Okay, so this angle has to be 39 degrees. This one has to be 39 degrees. And since we already decided when we looked at this thing that all of these angles are the same, well, guess what? They're all 39 degrees. Okay, and so that's one of these special things that can happen when we're looking at the diagonals of a rhombus.